All right. Whoa, little loud. So, been asked to use this mic by some students. So, can you guys hear me in the back okay? Am I too loud? All right. Okay. Um, so we'll kind of pick up where we left off. A couple things before we jump into material that I wanted to mention. And I put up an announcement yesterday. So for the syllabus, I updated it so that it has the GATA office hours and locations. I can't remember if I mentioned that in class or not. I'd updated it earlier in the week, but they gave me their office hours, and I had that early this week, so I've got that updated. Also, there are additional kind of tutoring sessions for the econ department for B251. So it's not specific to like just this course or this section, but there will be people there. They're typically graduate students in the econ program who will be there to help kind of answer one-on-one questions. So it's not like the CL sessions where they're given material where they kind of have almost teaching it like a class. They're just there if you have like one-off question, right? If you want to work through this problem with them or you have a question about this specific topic. So I don't remember the days and times off the top of my head, but they're all right here in that announcement. Okay. So trying to kind of give you all this idea of all these additional places. You can come talk to me. Had a lot of people show up yesterday asking questions in my office hours. So that's a good resource. But the graduate assistants and teaching assistants for this class, also they've got office hours. Here's these extra tutoring sessions. And what starts tonight? Those CL sessions, right? So once again, I know I've said this a lot, but I'm still getting people panicking about the one they're assigned to. Just because your name is on an assigned day and time on that sheet, does that mean that's the only one you can go to? No, you can go to any one that works for you this week, right? It's just kind of a way that if the university, someone had really, technically it's if they have a grade appeal, I can say I have this where I sorted where I gave them kind of their top preference, and there was a guaranteed seat at that location. But in practice, you can go to any CL session. They'll record your attendance, and you can get the extra credit, and you can change week to week. So don't panic about kind of whatever that assignment was. If your first preference that you answered on that collaborative learning session has changed, that's okay. All right, you can kind of go to whichever one works best for you this week. And when I say week, I think there's some students I'm getting some confusion. This Thursday and Monday, that's within the same week because it's the same week of material, right? When does the week reset? For us, our first class is on Tuesday. So the weeks for us are going to be like Tuesday to Monday, right? So those Monday CL sessions, your quiz isn't due till the end of the day Monday, so they're still going to be covering Module 2 material this Monday. Right, so Thursday, Monday, we'll still be going over Module 2, and then Tuesday, now we're in Module 3, okay? Any questions about any of that before we keep moving here? Okay. I will wait and do that at the end of class. So we'll dive into material here. From where we left off. So I kind of went through a little quick example at the end of class. I think some people probably, it would be beneficial for us to see another example because I did work through it kind of quick. And I want to make some key points that maybe I glossed over a little bit on Tuesday's class. So we had this kind of setup, and we had two countries, and if they were using all of their resources to produce two different goods, we had those numbers given to us. Okay, so just as kind of a reminder of what this looked like, that's not what I wanted to do. Sorry, there we go. So we had the U.S., and if they were only producing aircraft parts, it was 30. If they were only producing iPhones, it was 60. Thank you. Is that better? Still blurry? Let's see. Let me write some more stuff here. Maybe it'll pick it up. Well, this is not ideal. Try this. Man, this room it's locked. I have to use my laptop for one day. This is broken. All right, let's see if this helps. There we go. Turn it off and on. There's always a solution, right? So we had the US, we had aircraft parts, we had iPhones. We said if they were only producing aircraft parts 30, iPhones 60, we had India, different values, right? We then said the cost of one aircraft part to the US, we kind of drew out each country's own production possibilities curve, and we determined that that was 2 iPhones. And then, just to kind of save us time, India, we had their cost was 5 iPhones, okay? So let's think about this kind of hypothetical scenario. Just I want to have that information. We'll go back to that pretty quick. Let's say we started out and the US wants to produce 22.5 aircraft parts and India wants 5 aircraft parts, right? So we know the cost to each country. So if they're going to do it on their own, they're not going to trade. If the US wants to go to 22, oh, gosh, bless it. There we go. Now we can see it, right? Okay, sorry. I'm flustered here. So if instead of using all our resources to produce aircraft parts, the US only had what, 22.5? So I gave up how many aircraft parts? If we can't do this math, we're going to have a long semester. 7.5, right? So how many iPhones, if each aircraft part was costing me 2 iPhones, if I give up producing 7.5 aircraft, how many iPhones am I going to get back? If each aircraft part is worth 2, 7.5 times 2 is 15, right? Now for India, I think I had it set to be 5 aircraft parts. So if they're only producing aircraft parts, they can produce 10. So if they give up 5, how many iPhones are they going to get in return? Well, for them, each aircraft part is worth 5 iPhones. So they're going to have what? 25 iPhones, right? So this is like before trade. We can even think about it as, here's our production possibilities curves. If we put aircraft parts down here and iPhones up here, for the US, this was what? 60 to 30. And the point that they are producing currently is 15 iPhones, 22.5 aircraft parts, right? They're somewhere on their production possibilities curve, okay? Now, for India, we had what? 10, 50. Where are they producing at? Well, they're at a point of 5 and 25, okay? So without trade, both countries are producing at some point. Let's see, hope we don't lose the focus there. I was moving it around. We're both, at some point on our production possibilities curve. We're using all of our resources, right? So what's going to happen if we allow these countries to trade? So what did we say the terms of trade has to be in between? The 2 countries' costs, right? So our terms of trade must be strictly between 2 and 5. We kind of had this set up last class. We're going to kind of just work through some different values and kind of point some things out, you know, make sure we're really kind of okay with this. So let's say now that we decide that one aircraft part is worth 4 iPhones. I think I chose the number 3 last class. This is just a hypothetical value, right? We're going to just use, we can only show this for one value, where I'm going to show you that trade is beneficial. Now, if you go through the same thought experiment with any value in this range, you would still be able to show that trade would be beneficial for both countries. So we're going to kind of have here, let's say we wanted to get, and actually, do I want to use 4? We can. What did I use in the slides, though? Just make sure I'm lining this up with the slides. Well, I'm going to line this up with the slides just so we don't get kind of any confusion. We could do this for 4. We could do this for 3. We could do this for 2.5, any number in this range, okay? So I want to make sure I'm kind of matching up the numbers on the slides with what we're doing here, okay? So let's say if this is the terms of trade, what we're going to do is only have each country produce what they have the lowest cost in. So who has a comparative advantage? Who has the comparative advantage in aircraft part production? Who has the lower cost? The US. So we're going to rely on them to only produce aircraft parts. Who has to have a comparative advantage in iPhone production then? It's always the other person, right? Because when we do the cost, it's 1 over. We kind of talked about this last class. So they're only going to be producing iPhones. From here, we say, okay, look, if the US wanted to get to that same number of kind of aircraft parts that they were prior to trade, so let's say, is that what I did here? The slides, let me just make sure that's what I wanted. No, I'll do it the other way. So we'll scratch that. Let's say they wanted to get to that same number of iPhones, just to kind of be able to prove this to you. So let's say they want to get to 15 iPhones, but they're going to do it with trade, right? The agreed upon trade is that every aircraft part is worth 3 iPhones. So if the US wants to get 15 iPhones, right? How many aircraft parts are they going to have to give up? Yeah, how did you do that? Well, you know that if each aircraft part will get me 3 iPhones, if I take 15 and divide it by 3, that tells me that I need to give up 5 aircraft parts, right? But remember, that's how many I'm giving up. So what's the total amount now? 30 minus 5, or I have 20 aircraft parts remaining. Okay? So is the US better off after this trade? They've got the same number of iPhones, but they've got 2.5 more aircraft parts. So really, after trade, where are they? They were able to get 15 iPhones, 25 aircraft parts. They're at a point that was over their production possibilities curve or unattainable without trade. If they were going to want to produce at this point on their own, they can't. It's past their production possibilities curve. But with trade, they can get there. Now, same kind of thing for India. Okay, so they were producing 50 iPhones. They gave up 15 of them, so they're left with what? 35, right? They were trading 15 away to the US. Now, how many aircraft parts do they get from the US? 5, right? For every, you can kind of think about it this way, if I was giving up 15 iPhones, each aircraft part is worth 3 iPhones, I'm getting back 5 aircraft parts in return. So where is India after this trade? They're at 5 aircraft parts and 35 iPhones. Notice they're also getting to a point that was past their production possibilities curve if they were just doing this on their own. So this is just one hypothetical terms of trade value where we can show both these countries are better off with trade. Okay? Any questions there before we keep moving? So just kind of a similar example, but we're just using kind of slightly different values. So we kind of had this set up. And once again, like, where are these numbers coming from? It's just a hypothetical example. You could go through other ones as well. You know, you could choose different starting values and kind of still show that they're better off. It would just be different numbers, okay? So we had kind of before trade, after trade. We can see that they've got the same number. US had the same number of iPhones with more aircraft parts. They're better off. India, same number of aircraft parts, more iPhones. They're going to be better off after this trade as well, okay? All right, so we went through that. The next thing that we're going to do is think about, okay, we've got these individual production possibilities curves. Now, we talked about with trade, we can get kind of past those 2 points, right? Instead of just looking at one country's production possibilities curve, we're now going to look at, and I'll keep this over here just as kind of reference because we're going to keep using the same values. We're going to look at what we call like the economy-wide production possibilities curve. So this could be looking at the world economy, so take every country and kind of put them together, or it could be every individual citizen or you know, of whatever country you're looking at, every individual's production possibilities curve, add them all up to get that country's economy-wide production possibilities curve. Now, last class, I said we had to walk before we can run. We were keeping everything linear. So what's actually going to happen when we start to look at not an individual's production possibilities curve, but we want to look at an economy-wide production possibility, everybody. So here we have 2 countries. For the sake of making the math easy, and I'm never going to push you to do like every country, right? Assume these are the only 2 countries in the entire world, right? What would our worldwide economy production possibilities curve then look like? And we can do it with 2, and in the same process, we'll kind of extend it to think about what it would look like with every country. So if both of these countries are only producing iPhones, how many total would I have? Yeah, 60 from the US plus 50 from India, I'd be at this point of 110, okay? What if they're only producing aircraft parts? Well, 30 from the US, 10 from India, I'd be at a point of 40. Now, my economy-wide production possibilities curve is not going to be just a straight line between those 2 extremes where all resources are being used to produce only one type of good. Who am I going to want to rely on to produce that first aircraft part? Well, who can produce it at a lower cost? So who do I want to rely on to produce it? The US, right? So initially, the US will start producing aircraft parts. What would our economy-wide cost to those aircraft parts be? Well, their cost was 2, so it would be a slope of -2. Now, at a certain point, when the US is only producing aircraft parts, they no longer have any more resources to produce past 30, right? At that point, how many iPhones would we have? So if the US is using all of its resources to produce those 30 aircraft parts, who is the only person producing iPhones? So we would only have 50, right? So in a lot of these questions, if you look at the practice exam and eventually the quiz this week, if I ask you about what points are on the economy-wide production possibilities curve, a really good place to start would be to think about these 2 extreme points, and then this third point in the middle, which this represents what? Each person, or in this example, country, producing only whatever their comparative advantage good is, right? So the US had a comparative advantage in aircraft parts. They're only producing aircraft parts at this point, and India's only producing iPhones. Now, if I want to go past 30 aircraft parts, who do I have to start relying on? India. The US has used all of its resources. There, we've got what? Their cost was 5 iPhones, so our slope would be -5. So I can think about, this is my economy-wide production possibilities curve. And if I wanted to say, figure out, I don't know, let's say I wanted to know, okay, maybe I give you some hypothetical points and I say, is 35 aircraft parts, and let me think what I want here. Let's do 40 iPhones, right? Is that point on my curve? Well, if I'm looking at 35 aircraft parts, I know that moving past that point of 30, I'm going to have to start relying on India. So if I wanted to go from 30 to 35, how many iPhones would I have to give up? If I want 5 more aircraft parts, who's producing them now? India. What is their cost? 5 iPhones. So if I give up 5 aircraft parts and each one is 5 iPhones, 5 times 5 would be 25. So moving from this point down to here, I'd be losing 25 iPhones. So where would I actually be at on the curve? A point of 35 aircraft parts and 25 iPhones. This point is not my curve. In fact, this point would be unattainable for the economy-wide production possibility curve, or the entire economy, or the entire world. Okay. So I can kind of find the different points along this curve. When it comes to these questions for the quiz, a lot of the times, these points in the middle, yes, you can test them out, but as long as you can think about what these 3 points are, a lot of the times you can like rule out some other answers and kind of lead you to kind of potentially getting the correct answer of which one's on the curve or which one's not, right? If I told you 30 aircraft parts and 40 iPhones, how do you automatically know that's not on the curve? Well, because if I know 3050 is on the curve, 3040 must be production inefficient, right? We talked about these economy kind of wide, we talked about these zones last class: production efficient, inefficient, and then unattainable, okay? Any questions here before we keep moving? Okay, so what do we notice about this production possibilities curve, even with two countries? What's happening to its slope? It's getting steeper, which represents what? Costs are getting higher. If I want to produce more of something, what do I have to start doing? Relying on a country that can produce it at a higher cost, right? Because as I produce more, eventually I'm going to run out of the US's resources. And then I'm going to run out of India's. So then I'd have to go to the next country and the next. So it's just going to be getting steeper and steeper. So if we think about our kind of economy-wide production possibilities curve, we would say that it's really representing that when I produce more of something, what's happening to the cost? The costs are increasing. We've already kind of talked about this, right? As you do more of something, you put more hours towards an activity, right? You're giving up more and more important things to you. We said the marginal cost is going to be increasing. That's what our production possibilities curve shows us as well. As we want to produce more and more of a good, we start to have to rely on people who can produce it less and less effective or at higher and higher costs, okay? So you kind of think about, like I always say, if I'm thinking about the two goods are writing songs or writing economics papers, right? Eventually, if you want to have everybody in the economy writing songs, you get to me and they're absolute garbage, right? And the cost is insanely high because I can't write one song. And even if I took all the time in my life, and I could write several economics papers if I took all that time, right? So as you rely on, you want more and more of a good, you have to start relying on people who can produce it less and less efficiently, okay? Now, we also, once again, I jumped the gun a little bit last class, so here this, whoops, doesn't really, we've already talked about this. Any point below, just like for the individual production possibility curve, we said any point below that curve is inefficient. Any point above that curve is unattainable. Any point on the curve is production efficient. Okay? So nothing kind of really new there. So I'll draw this out a little bit more continuous for us. So instead of just two countries, it doesn't matter what two goods we're looking at. So here I could write this out in general terms. So I've got good X and good Y. Initially, whoever is producing good X is the person who can produce it at the lowest cost. So initially, my slope is going to be pretty close to what? Well, the lowest possible cost would be 0, right? So notice initially, my slope is pretty flat. But then at a certain point, whatever firm, country, or person I'm looking at, they've used all their resources. I have to start relying on people who can produce at a higher cost. So my slope will be a little bit steeper. And then I have to higher cost. My slope is steeper. Higher cost. My slope is steeper, right? So our economy-wide production possibilities curve, when we look at like every single individual within a country, it's going to be this nice kind of continuous bowed out graph representing that what is happening to the costs, my costs of producing this good, whatever it is, are increasing, right? In fact, well, before I do that, excuse me. So we said any point on this curve would be what? Efficient, or we want to be careful because we're going to talk about something else here in a second. We want to make sure we say it's production efficient. Any point above the curve was unattainable. And any point down here below the curve, we weren't using all of our resources. We could have been kind of producing more, and so we were inefficient, right? We were wasting resources. Okay? So with this idea of kind of in mind, I want to show you something, and then we'll start to talk about allocated efficiency. So if I had any good, any two goods, and I've got my production possibilities curve. If I wanted to map that out, so for every quantity of X, if I wanted to kind of put the cost of producing that number of units of good X, what would I do? Well, for the first one, I'd go up and I'd see, okay, what's the slope that represents my opportunity cost, or the cost of producing that very first unit of good X. So I would like plot that. I then say, okay, what about the second unit? Well, at the second unit, a little bit steeper, so my cost is now higher. I'd go down, I'd plot that. I would continue to do that for every single quantity of X, and really what that production possibilities curve is giving me is the marginal cost to producing one more unit of good X. So it's the marginal cost of producing one more unit of good X. What else could I throw on this graph that looks similar to something we've already talked about when it comes to choosing, well, what's the optimal amount of X to produce? Well, if I know the marginal cost, what else do I need? Marginal benefits, right? And we'll talk about that in a second. But once I have those marginal benefits, right, all I'm doing is the same thing that we talked about last week. We're going to find the last unit of that good X where the marginal benefit is equal to the marginal cost. Every unit before that, we know that the marginal benefit will be greater than the marginal cost, right? Because marginal benefits are declining, marginal costs are increasing. So we're looking for the point where the last unit produced, where they're equal. We would say that the country is indifferent about producing that unit. That point where marginal benefit is equal to the marginal cost, that's what we're going to call allocative efficiency. So when we're thinking about all the points on our curve, which one of these points would be inefficient? Well, this should be an easy one, this D. But what points would be production efficient? B and C, but also every other point on that blue line, right? So we've got multiple production efficient points, but there's only going to be one allocative efficient point. There's only going to be one quantity where that marginal benefit is equal to the marginal cost, okay? So, you can think about, right, even though we want more of a good, if the marginal kind of costs are increasing and the marginal benefits, we know as we have more of something, the marginal benefit is lower and lower. So you could think about this even in terms of like military. What's the optimal number of tanks for a country to build? Well, going from zero, well, actually, we'll do nuclear weapons. Going from 0 to 1 nuclear weapons, what's the marginal benefit of that? Very, very high, because now people don't want to mess with me because I might be able to retaliate, right? Or I at least have the threat. Now, what if I went from 100 to 101? I'm still going up by 1 unit, but having 101 nuclear weapons versus 100, what's the real marginal benefit there? Nothing. I'm equally as much of a threat to everybody else. I have about equal almost amount of retaliation. There'd be some additional benefit, right? But really, really small. So as we have more of something, we said that marginal benefit is going to be declining. The same thing applies at like an economy-wide level. So if we map out these marginal costs from our production possibilities curve, and for now, I'll kind of show you later on today where this would come from, but we know that we're going to have some declining marginal benefits. When we're looking for that allocative efficient quantity, it's just going to be that quantity where the marginal benefit of the last unit is equal to the marginal cost, right? Every unit here, the marginal benefit is above the marginal cost. This is the very last one where it's greater than or equal to. And so that would be kind of the optimal number of X to produce. We would then go up to our production possibilities curve. Not only have we determined what the optimal amount of X to produce is, we also would know if we're being production efficient, this would be the optimal amount of Y to produce. So notice what's going to be true about every allocative efficient point. It has to be production efficient, right? But every production efficient point, only one of those is allocative efficient, okay? Excuse me. Any questions on this idea? Like I said, it really kind of boils down to almost what we talked about last week, kind of this simple comparison of marginal benefit being greater than or equal to marginal cost. Yeah. Here, I was just showing you that if I wanted to go unit by unit, the marginal benefit for the first unit is greater than the marginal cost. So I produce the first unit. Is the marginal benefit greater than the marginal cost for the second unit? So I produce the second. So on and so forth, right? All the way up to that last unit where they're exactly equal to each other, right? So wasn't trying to like shade this in. I was just trying to kind of show for every unit here, that difference is positive, right? The marginal benefit is above our marginal cost, right? I would never produce past this point because for every unit over here, well, now my costs are greater than my benefits. That doesn't make any sense to produce those units. But I mean, in order to get to, if I had a hypothetical value, in order to produce the 50th unit, I've got to produce the first 49 as well, right? So I'm going to decide to produce all of these. The one that I'll stop at is wherever that marginal cost is equal to the marginal benefit. Yeah. Your argument, I think what you're thinking about is like, there's some, I mean, I understand what you're saying, but I don't necessarily know if you have 100 nuclear weapons versus 1,000, what really additional threat have you gained? I mean, you can still blow up most of whatever country you want to, or at least enough to be completely disruptive. If you had something weird where, I don't know, there was like a jump, we're not going to be looking at anything that has this, but like if you had a function where it took like a huge jump up at a specific quantity, I don't know if there was like some, what's the word? Like synergies of having, if I have 49, this system doesn't work, but as soon as I have 50, the system all of a sudden works. We won't be kind of looking at any examples like that in practice. Is there probably one that would exist? Maybe. It just makes the math harder, right? We would still be looking for where that last unit, where the marginal benefit is greater than marginal cost. If the marginal benefit for some reason all of a sudden does take a jump, it just shifts that point a little bit more to the right. Yep. All right. Where are we at on time? So we go to, okay. Any other questions here before we keep moving? Make sure we've got, okay. All right, so we talked about this idea of allocative efficiency, right? How we are just identifying where marginal cost is equal to marginal benefit. So we're now going to think about what's going to cause some changes to an economy's production possibilities curve. Okay? So the very first one is relatively easy, but we can kind of think about outward shifts in our production possibilities curve, which are generally caused by things like technology changes, population growth, or something that's changing productivity. So this is where last class I initially started showing you, thinking about, well, we had a certain number of labor hours, and we were saying if we use all those labor hours to produce one good, here was the quantity. And I had people asking me some questions like between class and after, like, are you going to make us use the hour example, like, and actually plot the production possibility? No, I'll always give you the quantities, but when it comes to the things that are going to be changing our production possibilities curve, I am going to expect you to know that link between hours it takes to produce something and the quantity. So it should be, I think, relatively obvious or easy, but like if it requires more hours for me to make something, using all of my resources, can I produce more or less of it? So if it takes me more hours to produce it, using all of my hours, I can produce less of it, right? If I have 100 hours and it takes me 100 hours to produce something, I can produce one. If it all of a sudden takes me only 50, so there, if that takes me less time, well, now how many can I produce? Now I can produce more. There's this inverse relationship between those two things, okay? So if I have something like, changes in productivity, where the same workers now, so if you think about the like the assembly line, the same number of workers after the assembly line was kind of applied to these, motor vehicle production facilities, the same number of labor hours could now produce more cars, right? Each worker, right? The cost to produce one car was now a smaller number of hours. So how many cars can we produce? Even more than we were before, right? So that kind of link between those two things is going to cause shifts in this production possibilities curve. If we just have more people, what happens to the number of labor hours we have? Even if people are the same level of productivity or have the same level of productivity, if I just have more people, I'm going to have more labor hours, right? I'm going to have more workers, right? So I can produce more. That's why countries that are larger in population size, right, we see they tend to have higher GDPs. Now, it's not one-to-one. Obviously, other things matter as well, how developed the country is. But population growth could cause these changes in our production possibilities curve. So what is this going to look like? Well, if I just have more labor hours, if I put them all to producing good Y, I'm going to be able to produce more of good Y. So my Y-intercept would go up. If I have more labor hours and I'm putting them all towards good X, I can now produce more good X. That intercept up is going to go up as well. So anything that we have that changes, that's going to impact both goods the same, will cause these nice parallel shifts in our production possibilities curve. Probably the number of labor hours, some type of like just general increase in productivity, not specific to one type of good, or some kind of technology change that would like hit every single industry the same, would cause these kind of parallel shifts in our production possibilities curve. So, if we think about, notice, if I'm looking at like marginal costs, right? Technically, like what is happening at every single, like keep producing the same amount of good X, it's actually going to change my costs. So even a shift in the production possibilities curve is going to change our allocated efficient point. Right? It's harder to see, but if I was looking at this amount of good X, this curve here is a little bit steeper than the point I would be at up here, because the actual slope is the same. We'd have to like draw this line out from the origin. We won't kind of dive in it because I'm not expecting you to know that, but like it would change some of our costs and potentially our allocated efficient points. Now, and usually we only think about these increases in our production possibilities curve because most of the time we're only like, to have it would be something like the Egyptians would be a good example maybe of all of a sudden there was some type of loss of technology. So what happens to the production possibilities curve if some technology is lost? It would shift down, right? We just don't see as many of those in practice, right? Like we generally don't see these kind of decreases in the production possibilities curve. Or probably, right, if we wipe out a large significant amount of the population, we could see a downward shift in the production possibilities curve as well. Yep. Yeah. Yep. So let's say we have a technology advancement, and if I have two goods, wheat and iPhones, right? But this technology advancement is like, I don't know, some chat GPT or some kind of tech thing. It's only going to impact iPhones, not impact wheat production, right? So if all of a sudden having, some new microchip that's going to allow me to, even there you could probably argue, I don't know, some part of the farming process maybe, but like, let's just assume it only impacts iPhones, doesn't impact wheat, whatever this technology change is. Well, what's going to happen if we use all resources to produce wheat, what's going to happen to that intercept? If there's a new technology, doesn't impact wheat, how much wheat can we produce? The exact same amount. But if we're producing iPhones, with this technology advancement, how many iPhones can I produce? More. So we're going to see, oh, there we go. Only one of the intercepts change, okay? So what ends up happening here, and I can kind of give you some idea of this. So let's say I had my original production possibilities curve. So I had what? Wheat, iPhones. Let's think about, I wanted to graph out, we'll call this marginal cost 1, because that was like our original marginal cost, right? And here's kind of our allocative efficient point that we were starting out with, okay? When I have a technology change that impacted only iPhones, right? At every single quantity, so if I were to look at the same quantity, what's happening to the slope of that production possibilities curve? It's getting steeper. So if it's getting steeper, what is that telling me about the cost to good X? They're getting, so a steeper curve, what does the slope of this production possibilities curve tell me? It tells me the cost of the x-axis good. So if this curve is getting steeper, the cost of producing wheat is going up, okay? If the steeper the curve, the higher the cost, right? And it kind of makes sense because now if I produce the same amount of wheat, I'm going to have to give up more iPhones because now the same worker can produce more iPhones because of this technology change that only impacted iPhones. So what's going to happen to this marginal cost curve? At every quantity, what's going to be true about the marginal cost? we said it was steeper, so the costs are going to be higher. So if you've taken like AP Micro or something before, starts to look like supply and demand a little bit, right? We're going to get this shift in our marginal cost. We'll eventually talk about similar to our supply curves. So what happens to this allocated efficient point? So now my allocated efficient point, the amount of wheat I should produce goes down a little bit. So that kind of makes sense, right? Whatever good is experiencing this technology change, am I going to be producing more or less of it? Well, if I'm producing less wheat, that means I'm going to be producing more of these iPhones. Because when I have this technology advancement, I'm becoming more efficient at producing that good. Intuitively, it kind of makes sense. I should want to be producing more of that good. And that only gets amplified if we then add in like the caveat we are allowed to trade as well, right? Because if, let's say I'm the only country that comes up with this technology advancement, well, what is this going to do? If it increases the cost of wheat, what's it going to do to the cost of my iPhones? Well, I'd have to do the inverse, right? But if the cost of wheat from this technology change for iPhones is going up, 1 over the cost of the x-axis good is how I get the cost of my y. So if the cost of wheat is going up, what has to happen to the cost of iPhones? It's going down. So what is this country more likely to have? A comparative advantage, right? If I have a lower cost of something, I'm more likely to have a comparative advantage. And if we allowed for trade, I'm more likely to be producing that good and then trading away to other countries. Okay? So all these things, hopefully we're starting to see, they're all kind of tied together, right? We're starting to get the bigger picture now once we get to this point. Okay? Any questions here before we keep moving? Okay. All right. So, all right. We already talked about this. So you can do this on either axis. I don't have an example, and for the sake of time, if we have time towards the end, maybe I'll show you one. But you could see something where the x-axis good is impacted as well. Well, hell, I'll just do it. So let's say, I can do it really quick for us. So let's say I had my production possibilities curve, and whatever good I have on my x-axis, if it experienced a technology change, what would I see? Well, if I'm producing y, same amount. If I'm producing x, I can now produce more. So if I had the x good see the technology advancement, what's happening to my slope at every quantity? It's getting flatter. So if the x-axis good has an increase in technology or something that kind of impacts how much we can produce, its costs are actually then going to go down, which same kind of story. If I'm seeing a technology advancement for this good, what am I more likely to now have? A comparative advantage, if I'm the only country that is experiencing that technology change. Okay. So nothing too crazy there. I think if there's anything else I want to say before we switch gears. So we can think about, usually I've been like having examples where I've got two specific types of goods, like wheat and iPhones or whatever it is. We can also try to understand these concepts through what we'll look at is the decision between investing our time and money as a country towards either capital goods or consumption goods, right? So capital goods are things like investments, right, towards projects that will have longer term payoffs, putting money towards research and development. You can even think about this at the firm level. Consumption goods, this would be, producing agricultural products that are going to be consumed today, right? They don't have any kind of long-term payoffs. So if we're making this decision between investing in capital and consumption goods, or maybe we're investing in our population, our education system, right? That would be kind of like a capital good, as opposed to investing in, I don't know. You could even argue that the housing market is somewhat a capital good, but investing in something like entertainment, right, being kind of a consumption good there. So if I'm a country making this decision kind of between groups of goods, so we don't even have to have just specific, we can think about I'm investing in capital versus consumption goods. I still have this setup where I can think about as I take more of my money and start to invest it into these capital goods, right? So as I move down this production possibilities curve, what happens? The slope is becoming steeper, so the marginal cost of this investment in the capital goods is getting higher and higher. Think about it this way. If I am only producing agricultural products, the very first few amount of labor hours or money I invest in the capital goods, I'm getting rid of food that, like, my country already had plenty of food, right? No one's going hungry. But at a certain point, if I start to invest almost all of the nation's money and labor hours into capital goods, I have almost no consumption goods. Well, first of all, my people might not have food to eat. So that investment is now was very, very costly, or they don't have anything that brings them enjoyment in life. So I'm starting to take away resources towards things that, you know, would make people just want to even be living in my country. So as we invest more and more into something, we're not investing more, you know, money into something else. So it becomes more and more costly, right? My populace has to start giving up more and more things that they don't want to. Right? Initially, they would be giving up things that had low value to them. As we take away more labor hours, more money to invest in these capital goods, now they have, you know, have to start giving up things that have higher and higher valuation to them. But it's the same kind of idea as what we were doing before. Okay. Now the difference would be we can also think about this investment in the capital goods. So we also have some output that the economy can produce. Okay. So we've got some function, and we won't work with like specific functions for this, but there is some like production function where if I take a certain amount of investment into capital, which is just things like machinery, the tools that my workers have available to them, labor, right? This is just the number of hours of labor I've got, whatever natural resources I have. So, right, I need iron to produce cars or whatever, you know, the good that I'm looking at is. And then a lot of times we'll kind of differentiate. We can think about it as capital. I mentioned already earlier, like the education system can be thought of as capital. Sometimes in these functions, you'll see they'll like notate it as human capital. Once again, don't worry too much about this because we're not going to be looking at specific functional forms, but we just know that this combination of things, if I have more labor, I can produce more of a certain product. If I have smarter workers, I can produce more. They can be more efficient, right? They're more productive. If I have more natural resources available to me, using all my resources, I can produce more of that good. And then we usually have this kind of multiplier in the front, which represents that economy, that firm, or that individual's like level of technology they have available to them, right? It's just a multiplier. If I have the same amount of labor, the same amount of capital, but I have better technology, it's just going to increase the total output I can get. So this output function, right, is going to be kind of dependent on technology. So if I think about this investment into capital, what should this relationship look like? As I invest more into capital, I give my workers more and more things to produce products, right? I'm giving them better computers. I'm giving them better machinery, my assembly line example earlier. What's going to happen as I increase capital? I should see an increase in output, right? So we have this relationship between investment and the capital, and here I'm just saying at the per worker level. Generally, these models will think about how much I'm investing per worker because that matters. If I invest $1 million and I have 100 workers, that's a lot more than investing $1 million when I've got 50 million workers, right? And so if we look at this investment in the capital and then the output that we're getting from that, so that was kind of that Q, right? The total number of this product that I'm getting, it's going to be an increasing relationship. But think about this. If I have workers and I say, I want you to produce cars for me, and then I give them no capital, I mean, can you produce an automobile from scratch by hand without any machinery? I mean, maybe it's potentially possible, but it would take you maybe your whole life to, you know, take the metal. I don't know. So, right, initially, if you don't give your workers any capital, they can't produce anything. That's why that point starts out down here at 0, 0. Now, when I first start to give them capital, what do I want to give them first? The thing that's going to make them the most productive, right? I'm going to buy the machine that can actually mold, like could actually mold the, you know, different car parts, like a CNC machine, so they can actually create, right, the parts needed to assemble. And then maybe what do I give them next? Well, now that they have the machine, I might want to give them, I don't know, some instruction or education, right? Invest into programs that give them knowledge about how to work the machine. Well, that wouldn't have been as valuable as actually just having the machine. And then eventually over time, what do I start giving my workers? A break room, right? Things that like make them like, okay, feel like my company cares, so I might work a little bit harder, but they're not having as near of a large of an impact as initially that capital, that first machine I was giving them to produce it. So kind of a weird kind of example there, but you can think about this in any other context. I first start giving my workers what I know will make them the most efficient. And then so that's what I first spend my money on. What do I spend my next $1 million on? What would make them the next highest thing that would make them most efficient? And then the next highest, the next. Well, over time, I'm choosing things that aren't adding near as much productivity to that worker. And so what's happening to the slope here? It's getting flatter, right? The equation is going up. I'm getting more output. As I invest in the capital, I'm always going to get more output from my workers. But I'm investing into capital that's less and less productive. So it's increasing, but at a decreasing rate. So what is the slope of this per worker or macroeconomic production possibility curve tell me? As I invest more and more into capital, the marginal output I'm getting, or we can think about this as the marginal benefit, is going down, right? So this kind of macroeconomic production possibilities curve, as we invest more and more, into capital, we're getting less and less return. So notice the first $100, the output increased from 0 to 500. The next $100, it only went from 500 to 900, so it only went up by 400. The next $100 I invested, it only went up from 900, so it only went up by 300. Every additional $100 I'm investing here, the return I'm getting in terms of output is lower and lower. So I've got this declining marginal output, right? Or this law of diminishing returns. Same kind of idea that we talked about with marginal benefit. As someone does more of something, the additional benefit of that activity is getting lower and lower. As I put more money into these capital investments, the return on investment or the output I'm getting, or the additional output, is getting lower and lower. I should say the marginal output, be very specific there. So if I had my marginal costs for my production possibilities curve, remember I said we could think about this choice between capital and consumption goods. If this gave me my marginal cost, well, when I'm thinking about this relationship between output and my capital investment, and we said it looks something like this, right? It was increasing, but at a decreasing rate. What is that going to allow me to then think about for these different amounts of levels of investment in the capital? What is the kind of marginal output? Well, it must be going down, right? We said that slope is getting flatter and flatter. Now, it's a little bit of additional work there to kind of think about, okay, I've now got kind of my output. I wanted to put these on the same graph. I probably should kind of try to convert whatever the value of these consumption goods and whatever the value of this output is into like dollars so that I could have the same units. But I've essentially got the marginal costs to capital. I've got the marginal output or the marginal benefit to these investments in capital. If I just put them on the same graph, right, because the x-axis is the same. It's my amount of investment into these capital goods. I've now got kind of the marginal, you can think about it as benefit, or the marginal output, the marginal output or the marginal benefit I'm getting. And then from over here on this graph, I had the marginal cost. What can I now find? That allocative efficient point, right? I can find the allocative efficient amount of capital investment I should be making, okay? So using kind of this production possibilities curve here about the choice between consumption and capital, using kind of this macroeconomic production possibilities curve about this kind of per worker production function, we can determine kind of what our optimal levels of capital are, okay? So I'll jump the gun a little bit here. I've got kind of this in the slides. But with this idea in mind, you can see both. Okay. So let's say I had this same kind of per worker, and I'm not writing per worker here. I'll make sure right? We said we kind of scaled this to make sure we're looking at same investment per worker. So if I had something that looked like this, right? We said we could map that out. Can we see this? There we go. So we had some marginal costs, and then we had these initial marginal benefits. And we could think about, here was our first allocative efficient point. Just going to kind of use like an AE to remain allocative efficient there. What's going to happen if I see something where, let's say I have a technology advancement, we're investing the same amount into capital, the same amount of capital, sorry, like the same amount of dollars. I now have like better technology investments that I can make, or technology that's going to be even more effective for my workers. So ChatGPT is probably a good example of this, right? I get the same amount of money invested in the same projects, and now with the help of ChatGPT, some of those projects are even more effective than they were before, right? So in fact, in my household, my wife and I coming up with like plans for what we're going to buy at the grocery store and cook for the rest of the week. We literally have outsourced that to ChatGPT and tell us like, give us a meal plan for 5 days for foods that 9-month-old babies can also eat, right? And it comes up with this whole thing, right? So like, we're putting in the same amount of capital investment into that, and we're getting even more output. So we would see something like this, right? A technology advancement would increase the same amount of capital invested, would lead to even higher amounts of output. So notice what is also happening to the slope at every single point. It's increasing, right? It's getting steeper. So that means that the additional benefit is getting higher and higher at every point. So what's happening to my marginal benefit? At every point, it is higher. So what is that going to do to the allocative efficient point? It's going to increase it. When I have technology that makes my capital investments even more effective, intuitively, am I going to want to invest more or less than I was before? Even more. That's what this is telling us, right? The allocative efficient investment of capital should be higher. Okay. So if we look at some of these companies that are, I think, ignorant, or like they kind of ignore that these technology changes are occurring, and they keep investing the same amount into their capital projects, like you're just going to fall behind, right? You're choosing a suboptimal point if you just stay at the same point after these technology changes happen. And this could be true at the economy level. It could also be true at the firm level, right? If you're resistant to change to some of these technology advancements, if you're making suboptimal decisions, you're going to fall behind those firms that are making optimal decisions. Okay. Any questions on that before we keep moving? Is this making sense? Are we starting to hopefully see some of the kind of connect the dots between the different topics that we're looking at? So I've got that here. I already kind of drew this out for us, but a technology advancement would kind of increase that kind of per worker production function, making, I think I've got it here, the same amount of investment. I now get even more output than I was before, but also the marginal output is higher as well. The marginal benefit of that in capital investment is now higher because the slope is getting a little bit steeper. Okay. So what we'll kind of end with, and I'll go through, I've got an example here I think is worthwhile to look at, but I won't go through like this too crazy because I think this should hopefully be an easy question on this week's quiz. So I'm telling you, you'll see a question like this on the quiz, right? So when it comes to capital investments, we can also think about this like any investment, right? And we can think about this, when we're investing certain amounts of our GDP into these capital products, what's the long-term payoff? So if you want to know what the growth rate of a certain investment would be, you take whatever your initial investment was. So when we're putting this in the context of like one economy or one country, it's whatever their old GDP was. So like, what was my GDP in the year 2000, right? If I then wanted to determine what is that country's GDP going to be in 2025, so 25 years later, if I was trying to make that projection, I would take their starting GDP, I would multiply that by 1 plus whatever this growth rate is. So this growth rate is going to be in terms of in decimal form. So if I wanted something like 5%, the growth rate would be 0.05. If I had a 10% growth rate, the growth rate I'm using this formula should be 0.1. Okay. So this growth rate will be in decimal form, and then I'll raise that to the power of whatever number of years I'm interested in. Okay? So in my example, that was 25. So this simple formula is a way that you can kind of figure out from a starting GDP or a starting investment into capital products, what would the payout be 5, 10 years down the road? Or what would the GDP be in 5, 10 years down the road? Now, there's going to be just a general rule. So this is where it gets a little tricky. The rule of, so in this equation, the growth rate you will use is in decimal form. I'm saying this slowly for a reason, right? When we're thinking about this rule of thumb, this is growth rate. We will think about it as like the actual percentage. So if I take 70 and let's say I had a growth rate of 10%, a general rule of thumb would be that if I take 70 and divide it by that growth rate of 10%, that would be 7. That's how many years it takes to double my investment. So if I can get like a mutual fund that's going to pay out 10%, I can double my money in 7 years. Now, it's not exact. It's a general rule of thumb. You would actually want to use this equation to see exactly what that would be. But it's pretty close, right? So don't underestimate the power of compound interest. I have this interest rate example that I put up on Canvas that I think is interesting. Well, I know to me it's interesting. Hopefully it's somewhat interesting to you guys. Oh, I zoomed in a little bit, probably too much. You might be able to use this in other classes. I don't know everybody's class thing. Okay. So I'm just choosing an easy amount here to kind of show you. If I invested $1, right? So in my example, if I invest $1, how many years at 2% is it going to take it to double? So my rule of thumb, I said, was take 70 and divide it by the percent growth rate. So here's 70 over 2. That dollar investment should double in 35 years. Sure enough, so I have like this all set up in Excel. I'm not going to make you guys reproduce this or do this in Excel. I'm just using this to quickly kind of show you and be able to change some things to show you like what your payment will be. Notice at 2%, it becomes $2 or it doubles at 35 years. What if instead it was, I don't know, 4%? Right? Well, I'd take 70 divided by 4, so I get what? Roughly 17.5. So it looks like it should double in between, 17 and 18 years. Right? And I could do this, I could change these interest rates. So this is why I gave this to you. If you're thinking about making investments of your own, like maybe a mutual fund, and I don't know, in 4 years. So in general, I put up, oh, now where is it? I'll pull it up again. This is also on Canvas. But like in general, and there's like dips, right? When we have like depressions or recessions. But on average, the S&P 500, if you have a mutual fund that's tied to that, it pays on average 10%. Now, if you're forced to like take your money out in these time periods, you're not going to get 10%. But on average, it's 10%. So if you think about investing into like a mutual fund tied to the S&P 500, and let's say, I don't know, I invested $1,000 and I want to know, in 4 years, what's the payoff going to be if I can get 10%? I'll have made $300, which doesn't sound like much, but I mean, that's about a third of my original investment. That's pretty good, right? And that's just in 3 years, right? If I think about if I make an investment like into a retirement account, if I make $1,000 investment, I can get 10%. Notice in 20 years, whoa, my amount invested has been almost multiplied by 7 at that point, right? So anytime you kind of have this amount, and that's just investing $1,000 one time, right? As retirement accounts, you continually are investing in them. So you can see that when growth rates are higher, or your interest rate you can get is higher, you're going to get paid back a lot more money. Now, if this isn't a growth rate, and instead this is an interest rate on a loan, what does that also mean? You're going to pay a lot more than the initial amount you borrowed if you get locked into kind of these higher rates, right? So you could play around with this file if you wanted to. Just kind of have it set up. You could even say, what if I can somehow get like a 50%? You can see how quickly it's going to go up. But even at really small growth rates, right, I'm doubling my amount invested, right, in 35 years, or I'm making a pretty significant amount pretty quickly, even when those growth rates are relatively low. I know for countries, they're not just thinking about the next 35 years, they're thinking about the next couple hundred, right? So investments into capital, even small amounts invested at low growth rates will become pretty large increases over time. All right, so that should do it for material. However, I've got two things that we need to look at before we get out of here. So the first one is going to be this quiz. Right? So I've got this published. I'm going to go in, change the due date on here. We're going to be what do I want this to be? 10. Oops, not what I want. 1050. Okay. So I'll kind of walk us through this because I ran a little bit out of time here. So I won't spend too much time on this, but it will be open till the end of class. Make sure you hit submit on these. It's due at 10:50. So I'll walk us through these. They should be pretty easy. We kind of already covered them today. Once again, a lot of the times I'm pretty nice on these. If you show up in class, it should be easy to get kind of the full credit. So we had two questions here. If I had more time to kind of give you to work on these, if we think about there's a technology advancement, I have nuclear and coal power. If I put nuclear power on the x-axis and there's a technology advancement that only impacts nuclear power, what is going to happen to my production possibilities curve? So the good that's on the x-axis saw an increase in technology. So what's going to happen? The y-intercept will remain the same. That x-intercept is going to go out, right? So what's going to happen? It's not going to shift inward or outward. And if this were a quiz, I would likely add in the word here, a parallel shift inward or outward, right? Unlike the weekly quizzes. We won't see a parallel shift. We're going to see just one of those intercepts change. So if it's the x-axis that's going out, what's happening to the slope of our curve? It's getting flatter, right? So if it's getting flatter, that means the x-axis good is becoming what? More or less costly. Yeah, the slope tells me the cost of the x-axis good, so less costly. Wi-Fi issues? Great. All right. Well, we'll see if by the end of class if it works. If not, obviously I'm not going to count it. But hopefully we can get it to work here in the next couple minutes. Just kind of hit refresh and hopefully we'll. So after we have this technology improvement, if we have these kind of per worker examples, so capital and output, yeah. No, it just doesn't matter. Yeah, it just whatever I tell you is on the x-axis, that's the one you'll put on the x-axis. Yep. So if we had the technology improvement instead, and we had this per worker production function, we're thinking about this investment into capital. If we're thinking about the goods that experience a technology change, so those goods we just said are going to become what? More or less costly. We said if it gets flatter, it became less costly. So it meant that they're going to see, right, if it's less costly, are they more or less likely to have, oh wait, I skipped the first part. If investing the same amount is going to lead to what? Higher or lower output per worker. Well, if I keep investing the same amount and I've seen that it shifts up a little bit, I'm going to get more output than I was before, right? Like even when I see just a change in one of those goods, it's not a parallel shift, but there are still going to be some points that used to be unattainable that no longer are, right? So seeing this technology improvement, it's going to increase the amount of output I'm getting no matter what level of investment into capital I'm at, right? So if we think about, where did we have this here? No matter what amount of investment into capital I'm at, where do I want this? I know I drew one for you guys. Where did I draw it? Here we go, right? If I keep investing, I'm getting more output, right? I can get to these higher points. But if it's getting flatter and my costs are going down, that means I'm more or less likely to have a comparative advantage. Lower costs means I'm more likely to have a comparative advantage, right? Comparative advantage is whoever can produce it at the lowest cost. So we're thinking about the same investment of capital in the worker is going to lead to higher output than it was before. That makes sense. We had a technology change. We had a technology advancement. However, because it changed the slope, made it less costly, it's going to make it more likely I also have a comparative advantage now. So that should be what? We get an increase in output per worker, and it's more likely that we have a comparative advantage. Right? So we should have kind of increase in more. And we said this one was what? That it becomes flatter. Okay. Any questions on that one before we keep moving here? So one more thing before we get out, just got 5 minutes, and you're gonna want to listen to this. Okay. So I'm also going to post after class today, not only this module quiz. So once again, those get released after the second section, just to kind of treat them both the same. So 12:30, this will be published. You'll also see the module 3 reading pop up at 12:30. This will be due the end of day Monday. Module reading is due at 11:50. We need a little bit of a buffer time there. I'm also going to release this first Canvas discussion, right? So in fact, I think it'll be released here as soon as we get done with class. So what it has this link. So it has this prompt. I've got a couple articles. It's this tying this idea of ChatGPT with productivity, giving you some hypothetical questions. You don't have to answer every single question I pose here. This is more for me to kind of get you thinking about some statements you could start to make that would kind of answer these questions that about how ChatGPT is tied to things like productivity. What types of goods might we see a lower or higher cost for? Because if they're more likely to be able to utilize ChatGPT. So thinking about this week's kind of material and how it would kind of tie in with ChatGPT, and then it'll make more sense as you kind of read through this prompt. Now, the other part of this assignment that you're going to want to pay attention to, and I gave you kind of a short description at the end of that Canvas discussion of how to do so, is I gave you a link. So part of this class, I want you to kind of start to get some tools, right, of looking things up on your own. I'm going to try to use Canvas discussions to do this. So this first one is just, we've got this OECD kind of data explorer. I just want you to access this database. Start to get familiar with kind of looking at data, playing around with some of these databases. So what I'm going to have you do is on this link, go to the economy section. We're going to go to productivity. Right? That's what we've been talking about. We're thinking about productivity when it comes to how much of a good we can produce, technology advancement, increasing our worker productivity. We're then going to come down here to that productivity database. So this recording will be on YouTube. I put a kind of description of the steps at the end of that Canvas discussion, but here this recording would be a good thing to go back to if you're having issues. So once we select that, we're going to want to make this price-based, the current prices, and we're going to want to change our unit of measure so that every country that we're looking at has kind of the same denomination. I think we don't want it to be in their own national currency, and you could choose, here we're going to choose this US dollars per hour, and then we're going to look at the table. Now this is the data, and in whatever statement you make about this tie of ChatGPT and what countries, what goods you might expect to see kind of change in productivity for, all I want you to do is choose a country or look at a group of countries and see, okay, what's been happening over time, specifically maybe in the most recent time periods, where we might see that this growth of AI, what has it been doing to productivity? Or in general, what countries would support the idea that these tech-heavy based goods might be impacted more by AI than countries that have probably relying more on or are producing higher levels of agricultural products, right? And so I just want you to mention one of the countries, some of these productivity points as part of your argument or part of your initial prompt. Once you post that initial prompt, I said you'll then reply to 2 other students, right? So this will all be done on the Canvas discussion board. And I'll have it set to be due at the end of the day next Friday. So you've got just over a week to kind of work on that. Obviously, probably not as much of a priority as the quiz and the module reading. Those are going to be due by the end of the day Monday. And I'll probably revisit this idea of the Canvas discussions just to clarify if anyone has any questions on Tuesday as well. But that due date will be set for next Friday. Okay? Did everyone get the Wi-Fi working, or was there still have issues? It ended up going? Okay. So hopefully, I'll probably try to start using those in-class quizzes a little bit earlier in the class, just in case we run into that issue. Other than that, look for an announcement. I may make my office hours only virtual Monday, depending on some things. Have a fun, safe weekend, and I will see you guys on Tuesday.